application SPV. Merkle trees are used extensively by SPV nodes. SPV nodes don't have all transactions and do not download full blocks, just block headers. In order to verify that a transaction is included in a block without having to download all the transactions in the block, they use an authentication path or Merkle path. Consider, for example, an SPV node that is interested in incoming payments to an address contained in its wallet. The SPV node will establish a Bloom filter on its connections to peers to limit the transactions received to only those containing addresses of interest. When a peer sees a transaction that matches the Bloom filter, it will send that block using a Merkle block message. The Merkle block message contains the block header as well as a Merkle path that links the transaction of interest to the Merkle root in the block. The SPV node can use this Merkle path to connect the transaction to the block and verify that the transaction is included in the block. The SPV node also uses the block header to link the block to the rest of the blockchain. The combination of these two links between the transaction and block and between the block and blockchain proves that the transaction is recorded in the blockchain. All in all, the SPV node will have received less than a kilobyte of data for the block header and the Merkle path, an amount of data that is more than 1,000 times less than a full block, about 1 megabyte currently. Bitcoin test blockchains. You might be surprised to learn that there is more than one Bitcoin blockchain. The main Bitcoin blockchain, the one created by Satoshi Nakamoto on January 3rd, 2009, the one with the Genesis block we studied in this chapter, is called mainnet. There are other Bitcoin blockchains that are used for testing purposes at this time: Testnet, Segnet and RegTest. Let's look at each in turn. Testnet, Bitcoin's testing playground. Testnet is the name of the test blockchain network and currency that is used for testing purposes. The testnet is fully featured live P2P network with wallets, test bitcoins, testnet coins, mining and all other features of mainnet. There are really only two differences. Testnet coins are meant to be worthless and mining difficulty should be low enough that anyone can mine testnet coins relatively easy, keeping them worthless. Any software development that is intended for production use on Bitcoin's mainnet should first be tested on testnet with test coins. This protects both the developers from monetary losses due to bugs and the network from unintended behavior due to bugs, keeping the coins worthless and the mining easy. However, it's not easy. Despite pleas from developers, some people use advanced mining equipment, GPUs and ASICs to mine on testnet. This increases the difficulty, makes it impossible to mine with a CPU, and eventually makes it difficult enough to get test coins that people start valuing them so they're not worthless. As a result, every now and then the testnet has to be scrapped and restarted from a new Genesis block, resetting the difficulty. The current testnet is called Testnet 3. The third iteration of testnet restarted in February 2011 to reset the difficulty from the previous testnet. Keep in mind that Testnet 3 is a large blockchain in excess of 20 GB. In early 2017, it would take a day or so to sync fully and use up resources on your computer. Not as much as mainnet, but not exactly lightweight either. One good way to run a testnet node is as a virtual machine image, e.g. VirtualBox Docker cloud server dedicated for that purpose. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.